The objectives of this example are to study 8-bit subtraction and to consider signed versus unsigned operation, and lastly, to look at overflow, which is the error that might occur after a subtraction. Let's begin. The goal of the problem is to write assembly language to perform the operation of n minus 10 and store the result into m, where m and n are 8-bit variables. If we were writing this in C, we would define a signed 8-bit variable using the char primitive. Conversely, if m and n were unsigned 8 bits, we would add the unsigned specification to the definition of m and n. To perform this operation, we'll bring the first number into a register, calculate the subtraction, and then store the result back into memory. We have chosen register A in this example because A is 8 bits wide, and the variable m and n are also 8 bits wide. When we execute the load A instruction, the 8-bit contents of memory location n are copied into register A. To perform the subtraction, we'll use the subtraction instruction. Again, we've chosen register A because it's 8 bits wide. The pound means immediate, so the number 10 will be subtracted from the accumulator. So after the sub A instruction, register A will contain the value of n minus 10. And the last step is to store the result into memory location m. And now, m is equal to n minus 10, and we're done. However, just like addition, if we take an 8-bit number and subtract a second 8-bit number from it, the result, the difference, is a 9-bit result, and we've stored that result into an 8-bit location, and so an error or an overflow might have occurred on the subtraction. There are 4 condition codes set after the subtract instruction. They are the Z bit if the subtraction yields a result of 0, the N bit, which is set if the result is negative, or in particular, if register A bit 7 is set. And then we have 2 overflow bits. The carry bit is set on an unsigned overflow, and the V bit is set on a signed overflow. When we develop assembly language, it's important for us to know whether the numbers are signed or unsigned. If m and n are unsigned, they exist in the range of 0 to 255, and after the subtract instruction, the C bit will be set on an overflow or an unsigned error, or in particular will be set if n minus 10 happen to be negative. Negative numbers aren't allowed in unsigned format. So, we could, if we wanted to, after a subtract instruction, check the carry bit and branch if the carry is set to some error condition, because if the carry is set, then the result of n minus 10 will not be correct. Conversely, if m and n are signed, they'll exist from minus 128 to plus 127, and the V bit will be set on a signed overflow, or in particular will be set if n minus 10 is less than negative 128, or greater than 127. In this particular case, this second condition couldn't have occurred. So if we wanted to, we could test after the subtract instruction the V bit and branch to an error if the V bit is set, meaning the result is incorrect. So, in summary, we saw the 8-bit subtraction, and we used an 8-bit subtraction instruction on register A to perform the operation. And second, we looked at the signed versus unsigned nature of the subtraction, looking at the C bit if the numbers were unsigned, and looking at the V bit if the numbers were signed in order to check for an error. Overflow occurs after subtraction because an 8-bit number minus another 8-bit number yields a 9-bit difference. And if we try to store that 9-bit number into an 8-bit variable, an overflow shall occur. And we can detect that overflow by either looking at the C bit if the numbers were unsigned, or looking at the V bit if the numbers were signed. Thank you very much.